Now the last thing that we have to cover in this particular lesson is least common multiple. I'm going to go back to the opening and look at the second part of that so that we can talk about what least common multiple is. At the bottom, the least common multiple of two whole numbers is the smallest whole number greater than 0 that is a multiple of each number. The least common multiple of two whole numbers, a and b, is denoted LCM parenthesis a comma b. And that's sort of similar, the last part of that sort of similar to what we said yesterday. We're going to represent, if we want to know how to find the least common multiple of two numbers like 10 and 20, we would write it that way. Now, a multiple is a product where you take the number as a factor and you multiply it by another factor and you get the multiple. So, I'm going to go to example 2 now to show you how to find the least common multiple. We're going to find the least common multiple of 12 and 18. The only method I'm going to show you is to list the multiples. They tell you to write the first 10 multiples. I'm going to cross that out and make it 5. I'm going to write the first 5 multiples of 12. So I simply make a list. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. And 12 times 5 is 60. Now I'm going to make some multiples for the other number. It says the first 10 multiples of 18. I'm going to make just the first 5 multiples of 18. So I again take 18 times 1, 18 times 2, 18 times 3, 18 times 4, and 18 times 5. Now I just want to find all the multiples that appear on both lists. Looking at these lists, I can see that there's a 36 on both lists. And since that's the only multiple that they have in common, it must also be the smallest or the least common multiple. So 36 is going to represent our least common multiple of 12 and 18. Now you ask yourself, well, what happens if we make a list of 5 multiples and there's nothing in common? Well, there's always going to be a least common multiple. You just have to make your list bigger. Keep making your list bigger until you find one that's common. If you find more than one that's common, we want to know what the smallest common or the least common multiple is, the smallest of those. Now I want to skip ahead to station 2. I'm going to do parts of these with you, and then I'm going to have you guys do some for homework tonight. We're going to skip the directions here, and we're going to go down to where it says, find the least common multiple of 9 and 12. So like before, there's only one method. Just list out the multiples. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. And 12 times 5 is 60. You can see that it's helpful to know your math facts when making these lists. It's one of the reasons why I had you guys study your flashcards this year. However, some I understand are going to be difficult, so you can use a calculator to assist you. If I look at my list, I can see that there's a 36 common, and that's the only common multiple. So therefore, I'm going to say the least common multiple of 9 and 12 is 36. I would like you guys to finish the next 4 problems as part of your homework, as well as some word problems. And I'll do a word problem with you, and then I'm going to have you guys finish those for homework as well. Now, just like we talked about greatest common factor yesterday, least common multiple, we're just going to list out the multiples and find the common, the smallest common one. But in word problems, we have to know when to find the least common multiple. This is also on the board, and I'm going to leave that there for the test, so you guys can look at that as well. But you want to look for questions like least, or smallest, or fewest in the question. That's a clue. Find the least common multiple. Another clue is that these problems usually involve some kind of scheduling. Like, when will they be at the same place at the same time again? And the classic least common multiple question deals with hot dogs and buns. And if we look back into our first word problem, oops, wrong question. Look back, now I'm lost. Look back into our first word problem. Letter A talks about hot dogs and hot dog buns. Hot dogs come packed in 10 in a package. Hot dog buns come packed 8 in a package. If we want one hot dog for each bun for a picnic with none left over, what is the least amount of each we need to buy? And how many packages of each item would we have to buy? So we know that hot dogs are 10 in a package and the buns are 8 in a package. You want to use one hot dog for every bun and nothing left over. I want to know what's the least amount of each we need to buy and how many packages of each item we have to buy. Notice least. Find the least common multiple. So I'm going to go hot dogs, that's 10, and buns, 8. I'm going to list out their first 5 multiples. I can see that 40 is in both lists. That tells me that the least common multiple of 8 and 10 is 40. But the question didn't ask for the least common multiple. It asked for what the least amount of hot dogs and hot dog buns we need to buy. That would be 40. So we would say the least amount of buns and hot dogs to buy would be 40. That answers the first part. Now the second part says, how many packages of each item would we have to buy? You can use your list to help figure this out. If I look at the hot dogs, I just want to count how many multiples it takes until I get to my least common multiple. It takes 1, 2, 3, 4 multiples to get there. That means it's going to take 4 packages of hot dogs. And then if I look at the buns list, it takes 1, 2, 3, 4, 5 multiples to get the least common multiple. That means we will buy 5 packages of buns. Now what I would like you guys to do is try letter B and letter C. Answer those in complete sentences. Show me some evidence of 3 reads. So once again, your homework tonight, you guys are going to finish station 2 here. These ones that I start off, and those 2 word problems, as well as station 4. I'd like you to finish up those 3 problems right there. Rewrite some equivalent expressions using the distributive property and the greatest common factor.